Okay, hello everyone, and good morning, good afternoon, depending on what part of the country you're in. My name is Kevin Goff, and thank you all for coming here today. This is the first week in a 13-part series, yes, a 13-part series on new features in SQL Server 2012. Now, I actually, for those who read Component Developer Magazine, otherwise known as Code Magazine, I'm one of the columnists in Code Magazine, and I have a regular column called The Baker's Dozen, where I present 13 different productivity tips on different technologies, usually SQL Server, or sometimes where SQL Server and .NET come together. And so, borrowing from the Baker's Dozen theme, since ever since I started that magazine, ever since I started that series, I almost think in terms of 13. Well, we've got 13 new feature areas over the next 13 weeks to talk about. And going to do just a couple of basic introductions, then we'll get started with the first topic here. So again, this is a 13-part series on new features in SQL Server 2012. Now, I'm a big fan of old TV shows, and some people remember the TV show Dragnet and the famous Sergeant Joe Friday, Just the Facts. So this is going to be a Just the Facts approach to presenting new capabilities in SQL Server 2012. Now, in just a minute, we're going to get started with the first topic, and that's going to be the new Columnstore index in SQL Server 2012. First of all, my bio, and actually the most important piece of information on here is the link where you can go grab these slides and all the demo code I'm going to be showing over the next 13 weeks. So the most important piece of information on here is my site, and it's just simply www.kevinsgoff.net. kevinsgoff.net. If you actually go out there right now, there's a section where you can pull down the slide deck and the demo code for this first week. Now, I'm a Microsoft MVP in the SQL Server area. As I mentioned, I write for Code Magazine. I've been involved in putting together a couple of different books. And during the day, I'm a combination of a trainer and a practice manager for a company called SetFocus. They are a Microsoft certified partner for learning solutions. They're based out of Parsippany, New Jersey, but we actually offer video conferencing training all throughout the country. And I invite everybody, if you want to see some of our free training library, you can go to freetraining.setfocus.com. Again, that's also mentioned here in the slide deck, as well as out on my website. So you can just go out to those pages and access those links. So again, the most important piece of information on here, because that's where the slide deck is found, is out in kevinsgoff.net. Now, my email address, if you want to drop me an email and ask me a question, feel free to do so. My email address, also here on the slides, is kgoff@kevinsgoff.net. Okay. Well, as I said, this is the first in a 13-part series. We're going to talk today about the new Columnstore index. Here's the schedule the rest of the way. So, for instance, next Friday, same time, same station, I'm going to be talking about some of the new Transact SQL enhancements in SQL Server 2012, and then just going to continue on down the line all the way through integration services, analysis services, some of the new features in the new business intelligence semantic model, the new capabilities in PowerPivot, what they've done with reporting services integration with SharePoint, and the new data visualization tool called PowerView. So as we get to those weeks, we'll be having coverage of those particular topics. So definitely doing an extended whirlwind tour around SQL Server 2012. SQL Server 2012 is an important release. Now, every release of SQL Server has always been important in some way, shape, or form. Well, this is definitely so. There's a lot of tremendous capability in the new version of the product. The product team has just done a phenomenal job with some of the new capabilities that are in here. And again, the demo code and the slides can be found on my site, just kevinsgoff.net. All right, well, the first thing we're going to talk about here today is the new Columnstore index in SQL Server 2012. This is a new index type that is available in the relational database engine. Now, I'm going to tab over to SQL Management Studio in just a couple minutes and do a demo and walk through some queries that are using this new index and see what it's all about. Well, the most important thing about this index is all you have to do is really use it, know when it's appropriate to use it, and you can immediately get some tremendous performance enhancements. Now, it's primarily for certain scenarios. The new Columnstore index is primarily for data warehousing and data mart scenarios. It's not likely something that you would use for transaction databases, and we'll see in just a little while why that is. But the features and the capabilities of this really lend themselves more to data warehousing and data mart scenarios where we upload data on some periodic basis, whether it's once a week, once a night, maybe twice a day, etc. Now, certain types of indexes are going to be beneficial for certain types of queries, and the new Columnstore index is really best for queries that scan large amounts of data and aggregate information over large sets of data in SQL Server. So that's why it really works best in data warehousing and data mart scenarios where maybe we want to look at sales for all of our products or all of our vendors, maybe over a course of a month or a quarter or a year, maybe compare one year to another, but take a look over all of our set of vendors, or maybe rank over our set of vendors to get maybe the top 5 or the top 10 or something like that. Now, my personal opinion, and I think you're going to feel the same way after seeing this if you haven't seen it already, this is one of the coolest things that's come out of SQL Server, and there have been a lot of great features out of SQL Server. This is a real game changer. This is going to open up enormous avenues for data warehousing applications. Now, I'm going to do a demo here in just a second and take a look at specifically what's involved with the Columnstore index. But the thing to remember about a Columnstore index is that compared to a normal database index in SQL Server, a row-based index, all the index data from each row is kept on a single page, and the data in each column is obviously spread across all the pages of an index. Well, a Columnstore index architecturally is very, very different, and the differences allow for some optimization and some compression that just isn't available with other types of indexes. The data from each column is kept together so that the data page contains just data from a single column, and as we're going to see, that opens up some enormous capabilities for optimization. So what I'm going to do here is I'm going to tab over to the SQL Server Management Studio. So I'm going to go over to my desktop and give this a second or two. And I'm going to come over to SQL Server Management Studio. Now, what I've done for this demo, I'm using the AdventureWorks 2008 R2 database because this is a demo I've been working with for months with some of the CTPs for SQL Server 2012. I took the purchase order header table, which I think many people who've worked with AdventureWorks have seen. The purchase order header table has basic order amounts by order date and by vendor, and I created a table called Big Purchase Order Header, and I've got about 10 million rows in there. And I've created 3 different indexes because we want to do a comparison across some of the types of indexes that we would create in a data warehousing environment. Well, first of all, I've got a clustered index that I've created ahead of time, and I've simply called it CL Big PO Header for clustered index for the Big Purchase Order Header table, and it's on the purchase order ID. Well, I've also created a non-clustered index, which obviously we've been able to do in different versions of SQL Server going back. I've created a non-clustered index as a covering index on the utilizing the vendor ID and the total due. And I'm going to take a look at some queries that are going to roll up total due by vendor. And then I've created, actually let me clarify here. I've created the non-clustered index here at the end. It's actually called IX and then BPO for Big Purchase Order covering index on the vendor ID to include the total due. And the one here in the middle is actually the new one. The new one is the non-clustered Columnstore index. This is the new one in SQL Server 2012. And I've created it on the columns I'm going to be querying on, the vendor ID and the total due. So the clustered index and the non-clustered covering index, those are ones that we've been able to do for a long time. But I've now created a Columnstore index, and I've called it IX BPO Columnstore. So I've got 3 indexes. Well, I'm going to turn on the IO statistics and the time statistics because I want to see some differences in time, as well as take a look at the execution plan for the same query that I'm going to run 3 different ways. I've got a query that's going to scan across my entire big purchase order header table. As I mentioned, Columnstore indexes really work best when they're scanning over large amounts of information. So queries with a high level of selectivity, where we're honing in on maybe just one vendor, might not perform as well as, or we might not get as much performance as we'll get out of a Columnstore index that's querying over a large number of rows, which we would typically see in data warehousing scenarios. So I'm going to query from the vendor table, and I'm going to join to the purchase order header table. And I'm essentially running the same query 3 different times here, and I've got a hint to use the 3 different indexes. So I'm going to use the Columnstore index first, I'm going to use the clustered index second, and I'm going to use the covering index third. I'm going to run the same query 3 times. So I will just simply highlight all 3 queries here, and I'll take execute. And I'll give this a few seconds. Now, the result sets are the same here. I've got roughly 300 and some vendors for each of the 3 result sets, so the numbers are the same. Now, the first query here that utilized the Columnstore index actually came back instantly. We'll take a look at some numbers in a minute. But that one came back instantly. The other 2 took longer. Well, if I go over to the execution plan, and I will scroll up so that everybody can see the results here. If I take a look at the execution plans for the same query run using the 3 different indexes, well, the first one that utilized the Columnstore index had a cost 5% relative to the rest of the batch here. Well, that in itself is pretty significant. The one that utilized the clustered index took 65% of the time, and then the remaining one that utilized the covering index, the cost was 30%. So right away, we see tremendous difference in performance. Now, we'll get into in a few minutes how specifically SQL Server is able to do that. Well, if I go over to the messages area just to take a look at some of the counts, with statistics IO and statistics time turned on, we see the numbers for the logical reads for all 3 queries. Well, the first one here that utilized the Columnstore index, we had about 4,158 logical reads. Well, compare that to the query that utilized the clustered index, where the number of logical reads was 27,000. And even the query that utilized the covering index was still 21,000. So we've got a difference in logical reads of a factor of roughly about 6 or 7. And we take a look at the execution times. Well, we're talking about just a little over 100 milliseconds CPU time utilizing the Columnstore index, and then we're talking about 4,500 milliseconds and 2,500 milliseconds utilizing either the clustered index or the covering index. So utilizing the same query with the 3 different indexes, we get a tremendous difference in performance and far fewer reads utilizing the Columnstore index. Now, I want to take a look at something else over in the execution plan. In the execution plan, first of all, for the query that utilized the Columnstore index, if I scroll out to the right here and come down a little bit, well, we see that there is a Columnstore index scan, so it's utilizing the Columnstore index to read across the data, but that's only part of the significance here. The other thing that's significant, if we take a look at some of the other plant operators here, we've got a hash match, and we've got a hash match as partial aggregate on the data, which is obviously one of the more expensive tasks that we would normally have in a query that's reading across a large set of rows. If I put the mouse over either one of these, notice there is an actual execution mode, and it says batch. Put the mouse over either one of those operators, there's an actual execution mode of batch. That's significant as well. Microsoft has implemented a new batch processing technique when running some of these typically more expensive operators, that is able to, as the name implies, take blocks of rows and blocks of about 1,000 rows or such, and is actually able to utilize some of the more advanced architectures you might have on processors to run some things in parallel and to perform those aggregations or the hash match significantly faster than what it could before. If we actually were to compare the I/O cost and the CPU cost for a hash match here, compared with a hash match down below, actually go try to search for that. The difference in the cost is actually significant. If we were to compare the I/O cost and the CPU cost, where the processing mode, the execution mode is basically row based, the cost there is significantly higher than it is for some of these historically more expensive operators when we're utilizing a column store index. Now I'm going to come back and take a look at these numbers and take a look at this query in just a few minutes. But I want to come back to the slides here. And so we'll transition over to the slides. So we've got a tremendous difference in performance with a query that's scanning over a large set of data, and 10 million rows is obviously child's play in a normal data mart where you're talking about hundreds of millions of rows and beyond. Well, the difference in performance is again going to be significant. Now, because of the nature of the column store index, Microsoft is actually utilizing a capability that has been in one of their other products for a couple of years now. Some people are probably familiar with a product called PowerPivot, which is actually an add-on for Excel that allows people to create basic almost star schema cubes against Excel data. Well, Microsoft is actually utilizing some of the same compression technique in that technology, which is known as VertiPaq. VertiPaq is a technology that was introduced in PowerPivot, and Microsoft is utilizing that here with the column store index. So we're getting compression rates. Now the compression rates are going to vary. There's some benchmarks that have been published that have shown compression rates as high as a factor of 13 or 14, sometimes maybe about 5 or 6. So it's going to depend upon the type of data you're dealing with. But compression factors of roughly 8 are pretty common with data once we create a column store index out of it. Now, if you're curious about the comparison with page compression in SQL Server, well, you're going to get roughly about twice the compression with a column store index as you would with page compression. So, as we saw a minute ago, the I/O statistics, the number of reads is dramatically reduced with a column store index because of what it's able to read into a server memory, and the fact that it actually also does some read-ahead reads, which can more efficiently be run in parallel, which again can help out with the performance. Now, there's one major restriction that we need to be aware of with a column store index. It is a read-only index. So we can really only use it in scenarios where we are updating data on some periodic basis. Again, overnight, once a week, twice a day. Because it's read-only, we can't create a Columnstore index on a table and then 3 seconds later try to insert a row into that table. We can't expect the index to be maintained. As a matter of fact, we'll get an error message from SQL Server. Get an error message that will very specifically say that we can't insert a row into a table that has a Columnstore index. So the technique is one that we typically would see when we load data into a data warehouse with either bulk inserts or maybe with a new merge capability in T-SQL, is to drop the indexes, reload the data, and then recreate the Columnstore index. So this is really for data warehousing or data mart scenarios where we're loading data on some periodic basis. And again, you can expect to get query performance with many queries of at least 10 times greater, in some instances more. So the major applications that can benefit from the Columnstore index are obviously any queries or reports against data warehouses or data marts. Now, even within these databases, there are some other restrictions of the Columnstore index I'm going to talk about later. Also, any loading of data from data warehouses into OLAP cubes. Some people might be using the data warehouse to turn around and populate an analysis services database. Well, sometimes updating an OLAP cube, depending on how much data you have, is a process that it's not uncommon to have it take 24 hours or longer. Well, this may help with performance if the queries that are reading from the data mart or from the data warehouse to populate the OLAP cube can take advantage of the Columnstore index. This potentially can increase the performance in the population of OLAP cubes. Now, in addition, some OLAP databases might use the rollup methodology, the relational OLAP methodology, where queries are being passed from the analysis services engine back to the SQL Server relational database. Well, it is very possible that the queries that pass through back to the relational database from the OLAP server may be able to utilize the Columnstore index as well. So for some of the people who have concerns about the performance of rollup, in some instances this can help out tremendously as well. And as we're going to see in a couple of weeks, when we take a look at the tabular model and analysis services that's available in the new business intelligence semantic model in SQL Server 2012, that utilizes the VertiPaq engine under the hood to get the same capabilities and the same performance we're seeing out of Columnstore indexes right here. Okay, going to I realize there's some questions, so going to go through some of these. Now, with some of the questions, I'm able to give an answer right away, and hopefully you can understand that with some questions, might need to table them, or might be ones that might take more than a minute or two to respond. And so what I'm going to do is, for the ones that I can reasonably respond to pretty quickly, going to do so here. Any ones where I might have to go look up something or research something, I'll certainly get back to you and put it back on my blog by the next day. Well, coming back through here, the new question is: the new batch execution on the hash join only available when working with Columnstore indexes, or we see it with non-Columnstore index execution plans? You'll only see it with Columnstore. You only see it with Columnstore indexes. So the optimizations that they've made with batch execution are only going to apply to the Columnstore indexes. If we're using a non-Columnstore index, it's going to revert to the traditional row-based processing execution, and we won't be getting the same performance benefits. Someone just mentioned that there's no source code in the downloadable zip, only the PowerPoint deck. My apologies for that. I might have only included the PowerPoint deck and not the SQL script that I'm going through. After we get finished, I'll go take a look at that, and I'll put the source code in. There's just one SQL script for right now, so my apologies. I'll get that up there. Okay. can we use Visual Studio that comes with SQL Server 2010 to edit and deploy reporting services projects and SSIS projects to a SQL 2008 R2 environment, or am I going to have Visual Studio 2008? I'll tell you what, there is an answer for that. Some of it gets into the new version of SQL Server Data Tools that is available with SQL Server 2012. I'll tell you what, I'd rather answer that one on my blog. So if you guys can, everybody can give me until over the weekend. I'll post the answers on these. There is an answer for there. It's more than just a yes or no, and so I'd rather qualify that with a post up on my blog. And then finally, is there such a thing as a partition column store index? You can implement as a workaround for the fact that we can't update data in a database as a column store index, at least not directly. We actually can utilize partitioning, and I'll tell you what, that's actually not something I was going to cover here, but I will. There is an answer for that, and I'll post a message for that as well. So thanks for the questions, very good questions, and I do promise that by over the weekend I'll get answers back up on my site. So good questions. Okay, going to continue here. Now, if you've done any reading of the column store index at all, if you've taken a look at any of the new books that have come out on SQL Server 2012, and there are one or two books that have actually hit the market already, or if you take a look at white papers that come from Microsoft, or just simply websites and blogs that have talked about the column store index, you probably have seen this picture over and over again many times. As a matter of fact, I didn't draw this. I have no artistic capabilities at all, but this diagram actually comes from one of the Microsoft white papers that just has a basic visualization of the difference between a row store and a column store. With a typical row store, we're obviously talking about multiple data rows per page. With a column store, we're talking about a very, very different structure. It's almost like a very finessed, almost a very sophisticated pivot, if you want to think of it that way. Each column is stored as a separate set of disk pages, where there's the greater capability of implementing compression and dealing with duplicated values across columns. Now, again, the compression that you get is going to vary depending on the type of data, but compression rates of a factor of 8 to 10 are very, very reachable with a column store index. And so Microsoft is actually using the VertiPaq technology that's found in PowerPivot, that's been around since Excel 2010 was released. It's utilizing that same technology under the hood to implement column store indexes. This is actually a pure column store data store, if you will. The reason I say that, and this is actually something that's been talked about on blogs comparing to other database vendors. Other database vendors have column store index capability as well, although it is more of a hybrid. This is actually a pure column store index. And so again, as we saw with the query a few minutes ago, the scan and the buffer hit rates are potentially going to be tremendous. Now, not every query that we run against a column store index will be able to take advantage of it. There are some restrictions, and in a few cases there are going to be some workarounds. One of them has to do with outer joins. I'm going to talk about them in just a few minutes. So moving on here, we saw a few minutes ago that there is a new batch processing mode that is available for some of the more expensive operations, and the ones that come to mind are hash match for joins and aggregations. Well, they can utilize batch mode when dealing with a column store index, and we can actually see in the execution plan, both the estimated and the actual execution plan, whether or not batch mode is being used. Now, batch mode is going to take advantage of 64-bit architecture. It's going to take advantage of parallelism. It's going to take advantage of the processor cache to be able to perform those more expensive operations significantly faster than before. Now, the way it works under the hood is that packets of approximately 1,000 rows are actually passed between operators using parallelism with the data represented as a vector. So on some websites that actually talk about the internals of the Columnstore index and the batch processing mode, they actually refer to this as a vector-based mode. And this reduces the CPU usage by a factor of 10. And some of the links on TechNet have actually talked about this improving CPU usage by a factor of 40. So it is significantly faster than row mode processing. Now, other execution plan operators are going to be able to utilize the batch processing mode as well. The hash match is the one that's talked about most frequently, but other ones like a filter and a compute scaler to read over a set of data are going to be able to utilize the batch processing mode as well. Now, there are some restrictions. There are going to be some queries that even if we use them against a Columnstore index, we might not necessarily get this batch processing mode. It might revert back to the more traditional row processing mode. For instance, if we do an outer join directly against Columnstore data, keyword there being directly, we won't get batch mode. I'm actually going to come back to Management Studio and talk about that. So let me flip back over to my desktop and give that a minute. Well, back over my desktop, let me scroll down here to take a look at another query that I've got. I'm going to do an outer join to get every vendor, regardless of whether they had purchase orders. So I'm just going to do a query from the vendor table and then a left outer join into my big purchase order header table with an index hint to use the Columnstore index. Well, this one a minute ago when I did the inner join just flew performance-wise. If I execute this again using the left outer join, well, we get a brief pause here. Before that came back instantly. So we'll sit here and wait for it to run. And wait. Well, when I take a look at the messages, well, the CPU time wasn't so hot there. Well, if I take a look at the execution plan and go to the hash match and for the outer join and for the aggregation, notice how the execution mode in the tooltip is row-based. We lost the batch capability. There's certain queries, there's certain statements that we just simply can't use directly against a column store, and a left outer join is one of them. So the hash match for the left outer join and the hash match for the aggregation both use the row execution mode. So even though this is still utilized in the Columnstore index, it can't implement the more advanced formulas utilizing a left outer join directly. Well, what we can do in that case, and what developers might do anyway in a query like this, if we pre-aggregate, if we pre-retrieve the data in the Columnstore index by itself, and then do a left outer join against that pre-aggregated result set, then we'll get the batch mode back. So if I utilize a common table expression to pre-aggregate the purchase order header data and group it by vendor ID, and then in my one line of code utilizing the common table expression, do a left join between the vendor table and that pre-aggregated result. If I execute this, well, it comes back right away. And if I go to the execution plan and take a look at the hash match, well, now it's back to utilizing batch mode. So it's the advanced algorithms that are able to take advantage of the processor, able to take advantage of the fact that I'm running on a 64-bit machine right now. That logic is going to kick in. And obviously we see a huge increase in performance. And even if I go back and run the first one again, well, again, it's still going to take several seconds because we're doing a left join and trying to do the aggregation of data all at the same time. and the algorithm just simply isn't set up for that. And so we are back in the execution plan to getting a row-based execution for both the hash match for the aggregation and the join. Okay, so let me come back to my slides here. Now, another restriction is that we can't utilize a union all. A union all is not going to leverage batch mode either. It's going to revert to the row processing mode. And in addition, if we utilize a not in with a subquery, we're going to lose the batch mode as well. Now, if you use not in with a specific set of scalar values, that's a different story. But if we actually use not in with a subquery, we also will lose the batch process, the batch mode. So even if we have a column store index, it's not a guarantee that every query is going to be able to take advantage of the new batch processing mode. Now, a general recommendation that you'll see in a lot of websites and with good reason is to include all the columns from the table in the column store index. So if we have say 15 columns in a fact table that's in a data mart or in a data warehouse, you would want to include all the columns in the column store index. Okay, well, coming forward here, the syntax, we actually saw it in the script a few minutes ago. The syntax is very simple. It is just simply create non-clustered column store index, and we give it a name on the table, and then we reference the columns, ideally all of them, and it does not matter the order of the columns. It does not matter if we put total due in front of vendor ID or after vendor ID, we're going to get the same performance. So the order here does not matter. Now, you can only have one column store index per table, and it cannot be clustered. It's going to be a non-clustered index, so we can't create a clustered column store index. We can only create a non-clustered column store index and just one per table. Now, in just a minute, going to go through some of the other restrictions as far as what data types we can use in a column store index and which ones we can't. So just jumping forward here. Some of the restrictions. Now, some of these are understandable. As I said, it can't be a clustered index. It cannot cannot serve directly as in a primary key, foreign key relationship as an index with other tables. It cannot include sparse columns. It cannot be used with tables that are part of change data capture, which was new in SQL Server 2008, or with file stream data. We can use it with the quote-unquote traditional data types. So fixed width character, varchars up to a certain point. I'll explain that in a minute. Money columns, decimal columns, integer columns. The traditional data types we can use fine, date, time, and so forth. But here's some of the ones we can't use. Any binary, text, image, or row version or timestamp data types cannot be in a column store index. Some of the more advanced CLR data types like the hierarchy ID, which was introduced in SQL Server 2008, or any geospatial data can't be used in a column store index, nor can we use it with any data types that were created with the max keyword. So if you were utilizing something like a varchar max in a database table, maybe because you were storing passages from books or passages from contracts or things like that, where you need to store a tremendous amount of data in a particular varchar, anything created with a varchar max cannot participate in a column store index. And we can't modify the index either with an alter statement. We have to drop it and recreate it. And it also, along with it can't participate with change data capture. It also can't participate in replication. So there are some restrictions with the column store index. And as I said, it is a read-only index. If I went back to Management Studio and I tried to insert a row into that table on which I created the Columnstore index, SQL Server would generate an error message. We can only build that index and essentially have it as a read-only index and then drop it and recreate it once we load new data into a data warehouse or a data mart on some periodic basis. So it's not going to be practical for a transaction database, for an OLTP database where we're hitting it on an on-demand basis. Not going to be practical to drop that index and recreate it every time. So this is primarily for the data warehousing, data mart scenarios, and also we're going to get the biggest bang for the buck on queries that read over a large amount of data. Okay, now the performance from the queries that I ran just a few minutes ago, utilizing the clustered index, the new Columnstore index, and a non-clustered covering index. The reason I included this is because in some demos that I've done and that other people have done in the past, just comparing a clustered index to a Columnstore index, some people ask the question, well, what happens if you create a covering index that includes all the columns in your query, thinking that would compete pretty well with a Columnstore index? Well, a covering index is going to perform in many of these queries better than just a clustered index. So, whoops, jump forward here, my mistake. So we see the difference in CPU time, and we see the difference in the number of reads. So down here, a clustered index is going to take longer than a non-clustered index, and the number of logical reads is going to be higher. But then when you throw a Columnstore index into the mix, there's just absolutely no contest. The CPU time is just a fraction of it is with either the clustered index or the non-clustered covering index. And the logical reads, again, we're talking about a factor of 5 or 6 or 7 to 1. Now we will see with the Columnstore index, in some cases, we will see read-ahead reads. And this is, again, something that SQL Server has optimized. It's able to read ahead a tremendous amount of the Columnstore into the server cache to be able to query against it more efficiently. So the differences in performance when we have queries that can utilize the Columnstore index and use them effectively, we get just a huge difference in performance. Okay, so jumping forward here. I'm actually going to finish a little early here, just one last slide here so I can actually talk about a few things at the end. Some recommended reading. Now, you can do a web search. You can go up on Bing and search on Columnstore index in SQL Server 2012 and find some great information on many different blogs. These are just a few of them. On technet.microsoft.com, there are actually two very, very good links. One is just a general frequently asked questions on the Columnstore index, and there's another very good one on performance tuning, on queries that will optimize the Columnstore index and the batch mode, and which ones won't. The union, or excuse me, not the union, but the left outer join is actually one discussion that they have up there. Actually, have several other ones as well. So if you want to do some reading on where the Columnstore index is going to give you tremendous increase in performance, these two links are very, very good. Also, I think most people know Dave on blog.sqlauthority.com. Tremendous blog, tremendous writer, great person, and he's got a couple of blog entries on the new Columnstore index. He actually has a video up there as well. He actually has a video for people who don't have SQL Server 2012 and just want to see it in action the same way I've done it here. He's got a video that covers the Columnstore. He's got a video that covers the Columnstore index. Now, again, you could probably have about 5 pages of slides here of just links for the Columnstore index with good information, but that's actually a start. So, what's unusual for me, normally on presentations, I'm usually pressed for trying to finish everything, but finished a few minutes early here. Now, I'm actually going to go up, if you don't have the ability to go up to a browser, I'm going to go up to my site right now. Again, it's just kevinsgoff.net. This is my blog, and just a little bit of information about this 13-part series. So when you go to my blog, on the right-hand side, there's a category for Microsoft Webcasts. So all you have to do is just go to kevinsgoff.net and go to Microsoft Webcasts, and any information related to these webcasts over the next 13 weeks, I'm actually going to have in this category. So by sometime over the weekend, the questions that I'm going to post some answers to, I'll actually post up here. So this will be our portal, so to speak, for the content. And as the new downloads become available, they'll be here. It's just simply a zip with the slide deck, and should have been the SQL script. My apologies for that. Afterwards, I'll get that SQL script up there, and so the zip file will have both the slide deck and the SQL script. And so next week, on the morning of the demo, the next zip will be up there. Now, next week, just to give a little preview of what we're going to talk about next week. Next week, we're actually going to look at the new T-SQL features. So coming back to my slide deck here. Now, some presentations are going to be different. Here, not a whole lot of code to show because there's not really a whole lot that we do with. Oops, come back to my slide deck. Not much we need to do code-wise with this, so this is really more a matter of where we can use it and what capabilities we get out of it. Next week, going to be spending a lot more time over in Management Studio taking a look at the new T-SQL enhancements. There are a number of language enhancements that are in SQL Server 2012. Now, every version of SQL Server has had a new set of T-SQL features. In SQL 2005, there were just a ton of new language features. In 2008, maybe not necessarily the same quantity of features, but certainly some important ones like grouping sets, which is one of my personal favorites. Well, in SQL Server 2012, there are plenty of new language enhancements as well. There is the ability to create a new sequence object in a database. There are some new window functions for statistical and maybe some analytic queries that we want to run against data. To do things like lag and lead over a set of rows, or maybe to get something like a percentile ranking or a median average. Well, there's some new capabilities that do that and more. So we're going to look at those next week. So we got about a dozen different code samples next week I'm going to be going through when we look at the new T-SQL enhancements. So there's the schedule here. Just going to be going through all the different capabilities that are going to be of interest to different application developers who want to know what's in SQL Server 2012. One of my personal favorites, and I personally can't wait to get to it, is the new capabilities in integration services. If you use SSIS, if you used it in the past, you will probably love, I know I love the new capabilities in SSIS 2012. They have implemented some new features that are tremendous. And so they're large enough that we're actually going to have two parts to cover. Okay, well, take a look at a few questions over here. Someone asked, can I install SQL Server 2012 over SQL Server 2008 R2? The answer is yes, you can, and I'm actually doing it right now. On the machine that I'm running, I have an instance of SQL Server 2008 R2, and I also have SQL Server 2012 installed. Now, in many instances, people are going to want to put that on a separate machine or in a separate box or as a separate VM instance. But I'm actually able to run both 2008 R2 and 2012. Now, I've only been doing it for a short period of time, and obviously SQL Server 2012 has just been released in manufacturing. But I'm actually running both now. As far as recommendations, I think I might want to talk to some other people and see what they've been doing with it, see if they've run into any issues. But so far, knock on wood, I've got two different instances and have not run into any issues. This is just simply on a development machine. In a production environment, might be a different story. But I'll see what I can find out. Okay, well, again, let me come back to to the first slide here with my bio. Again, my website is just kevinsgoff.net. So if you go to that site and go to the, it's actually both in the download as well as I have a separate category just for these webcasts. The slide deck, and I'll get the demo code up there right after we're finished here. And also a shout out to the company I work for. I work for a company called SetFocus, where we have a free training portal that is just freetraining.setfocus.com. We have over 100 hours of free training on .NET and SQL Server and business intelligence and SharePoint. I'm one of the trainers there and involved in putting together some curriculum for those areas. Well, thank you all for coming. Look forward to hearing from people. If anybody has suggestions for things to make this even more valuable for you, please feel free to email me and let me know if there's anything that you'd like me to cover. Might not necessarily be able to cover it the next week, but certainly try to fit it in as best I can, or at least blog about it. So definitely welcome the feedback. So feel free to contact me. So thank you all for coming, and everybody have a great weekend, and hopefully see everybody same time, same station next Friday when we take a look at the new language features in T-SQL 2012.